From the graph we have also discussed that the heavier elements are suitable for fission reaction, where the lighter elements are suitable for fusion reaction. Now there are certain particular nuclear reactions which occurs in atom bomb, that is basically the uranium 235's fission is occurred in atom bomb, in which uranium 235 nucleus is bombarded with a slow moving neutron. This slow moving neutron enters into the nucleus, increases its size. As a result, nuclear force is almost zero, so different parts of the nucleus will be fragmented, flying away, producing one beryllium and one krypton. In an addition, it produces 3 neutron. In an addition, after the reaction, initially it is bombarded with a single neutron, and from the reaction 3 neutrons will be coming out. Now these 3 neutrons will attack 3 more uranium nucleus. So again 9 neutrons are now available after breaking of 3. Then those 9 will attack further 9, and each of the electron will remove 3. So next, how many neutrons are removed? 27. So in this way, like a chain reaction, entire uranium nucleuses will be fissioned, and as a result huge energy is coming out. Okay, so this one is the nuclear fission reaction. The exact calculation of the energy is given, that is for a single nucleus of uranium 235, if it is fissioned, the energy coming out is nearly 200 mega electron volt. 200 MeV energy is released in a single reaction. Okay. Now, in case of fusion, there are 2 types of fusion that we have to study. One is the fusion of hydrogen. 4 normal hydrogen, that is 1H1, is actually combining together or fused together to produce helium. This reaction requires very huge amount of energy and cannot be performed in Earth. This energy is the source of the fuel of any star. Okay, so 4 hydrogen together produces helium and producing energy, and in a particular reaction 25 MeV energy is released due to the addition of 4 hydrogen. Due to the fusion of 4 hydrogen atoms together, there is a release of nearly 25 MeV of energy. This is the source of energy of any stars. Clear? Now, stars have a very large temperature, that's why this fusion can start. But in Earth, we cannot produce that much of temperature similar to the core of the star. So how to produce fusion? We can do the fusion with heavier hydrogen. Heavier hydrogen means deuterium, the hydrogen isotopes. One is deuterium, another is tritium, 1H2 and 1H3. These 2 can be fused together. As a result, there produces helium and releases energy. Helium and producing energy. Okay, this reaction can be done in Earth. This is the reaction of hydrogen bomb. Hydrogen bomb, which releases nearly 3.4 MeV of energy in a single reaction. 3.4 MeV of energy. Now, you probably heard about this word that energy released in fission is less than energy released in fusion. So fusion is more dangerous, and it shows that if you consider the man-made fusion, that is deuterium and tritium fusion, you will get from a reaction 3.4 MeV energy, whereas for a man-made fission reaction of uranium 235, you will get nearly 200 MeV of energy. Then if I ask you how we can say that hydrogen bomb is producing more energy? Fission reaction. Fission reaction is not producing more energy. Though it is 200 MeV, it looks that it is greater, but fusion reaction actually produces more energy. How? How 3.4 MeV cannot be greater than 200 MeV? But we say that fusion is more dangerous. Why? Because see, whenever you are doing the fission of a uranium-235, what is the amount of mass that you are taking? One uranium nucleus and one neutron. And when you are doing the fusion reaction of 1H2 and 1H3, so you are taking one deuterium and one tritium. So calculate the total mass of deuterium and tritium and calculate the total mass of uranium-235 and neutron. Which one is higher? Deuterium means isotope of hydrogen. So hydrogen is very lighter element. So deuterium tritium mass is very negligible, very small compared to the mass of the uranium and the neutron. Because uranium is 235, 92U235 means large amount of nucleons are there. So total mass is very high, and in spite of that total mass, it can only produce 200 MeV of energy. Whereas if you are taking deuterium and tritium, if the deuterium and tritium's total mass, that amount of mass is taken which is equal to the mass of the uranium and neutron, then it can produce much more energy than 200 MeV. Because only one deuterium, one tritium produces 3.4 MeV. Now if the deuterium and tritium's total mass is taken by more and more molecules, more and more nucleus, such that their total mass is equivalent to the mass of a uranium. In that case, this fusion reaction can generate much more energy than 200 MeV. So it is considered that fusion is much more dangerous than fission reaction. So hydrogen bomb is more dangerous than atom bomb. Okay. So these are the cases of the fission and fusion reaction, and another question may come from this. In the nuclear reactor, we use controlled chain reaction. Generally, this fission reaction is called uncontrolled, because due to this chain reaction procedure, more and more neutron will be produced, and as a result, entire mass will be fissioned, so large energy will be released. Now, if we want to use fission reaction in a nuclear reactor, means we have to do controlled reaction, because if there is chain reaction occurring, the nuclear reactor will burst. So controlled reaction means reaction after certain time I can stop. I will not allow the chain reaction, uncontrolled chain reaction. So there should be some material which will absorb neutron, because 3 neutrons are produced in each reaction. So out of them, 2 of the neutrons will be absorbed by some other material and taken away. Then those neutrons are not available for initiating further fission reaction, so reaction will stop and it will be controlled. Okay. Now for this, which material should be used? It is, you must remember this one, that cadmium rod. Cadmium material made rod is used for neutron absorber. This absorbs the neutron, as a result the fission reaction stops. So whenever this type of question comes, this is just an information based question. Remember that it is the cadmium rod which can absorb neutron. Okay. Cadmium rod. This is used as neutron absorber in nuclear reactors. Now, there is another part previously in this chapter, that is the natural radioactivity, but natural radioactivity is not in the new syllabus. Radioactivity, radioactive decay and all these things, alpha, beta, gamma and all this are not in the new syllabus. Now, in the last class we asked a question that beta particle means electron, and electron is not in the nucleus, then how electrons come, beta particle is coming out from the nucleus. That is, inside the nucleus, neutron is the uncharged particle, proton is the charged particle, and continuously inside the nucleus proton is converting to the neutron and neutron is converted to proton. So this one is continuously going on. Now when a neutron converts to the proton, neutron is uncharged, so two charged particle will be produced. One is proton, that is positively charged, then other charged particle produced is electron, and that electron is coming out as beta particle. And due to this interconversion of neutron and proton inside the nucleus, that is another reason for producing that huge attractive nuclear force. Because if the neutrons and protons are not exchanged or converted to one another, then in that case the strong nuclear force will not be produced. So during this reaction, a proton is converted to a neutron is converted to a proton, producing one electron and some other particles also. Neutrino will be produced in that case, but we don't require that. Only we have to remember that while the neutron is converted to the proton, then due to the conservation of charge, one negatively charged particle must be produced, and that particle produced is simply the electron, and that electron is coming out from the nucleus, which is called beta particle. Okay. Now I will ask you one more question from this. That is, suppose in a test tube, there are two test tubes. In the first test tube, we put 100 gram of radium. In this test tube, I also put 100 gram of radium. In both the test tube, I put 100 gram of radium. Radium is a radioactive element, so radioactive decay will continuously coming out from these two samples. Now, first test tube remains as it is. In the second test tube, I poured some sulfuric acid until entire radium is converted to radium sulfate, RaSO4. Okay, I pour sulfuric acid in the second test tube until entire radium is converted to radium sulfate. Now, which test tube will show more radioactivity? Which test tube will show more radioactivity? Test tube 1 or test tube 2? Test tube 1 is elemental radium of 100 gram. Test tube 2, initially 100 gram elemental radium is given, but now sulfuric acid is added by adequate amount such that entire radium is converted to radium sulfate salt. Now, which test tube will show more radioactivity? Why? Okay, any other explanation from anyone? Both test tube will show same radioactivity. Why? Because what is the amount of radioactive element in both the test tube? 100 gram. Second test tube, there is a chemical reaction. Chemical reaction is occurred in valence band. Chemical reaction means reaction of combination or bonding is formed in valence band, between the valence band electrons. Chemical reaction cannot alter nuclear phenomena, and radioactivity is a nuclear phenomena. So being a nuclear phenomena, radioactivity will be untouched in chemical reaction. So chemical reaction cannot alter the radioactivity. Since chemical reaction is not occurring inside nucleus, it is occurring in valence band. Okay, so since the mass of the elemental radium is same in both, because that is the radium is the only radioactive element, sulfate is not a radioactive part, so the radioactive decay rate will remain same. And if the mass of the radium is differed, then only decay rate will differ. Okay, more mass means decay rate will be more. This you have to remember only, because in other portions and all this calculation of the decay constant and all this, those are not in the new syllabus. So this one is a conceptual question, that's why I discussed this conceptual question. Now another thing, suppose I have a nucleus of gold, another is the nucleus of iron, another is nucleus of sodium. Which nucleus has more density? Which is more dense among sodium, gold, iron? Nucleus is more dense, means mass per unit volume of the nucleus is more in which material? Gold. Why? It is costly. See what happens. I will write first a particular thing, that radius of the nucleus is directly proportional to the mass number to the power 1/3. This is a general relation which was discovered by a scientist called Millikan oil drop experiment. So from that, this general result is referred as R proportional to a to the power 1/3. Means radius of the nucleus will be directly proportional to the mass number to the power 1/3. So mass number increases means radius will increase. Now I can consider here one constant, that is R equal to R0 a to the power 1/3, where R0 is a constant which is actually the radius of the hydrogen, because A equal to 1 for hydrogen, normal hydrogen, 1H1, A is 1, so that is the radius of hydrogen, that is considered as constant. Okay, minimum. Now in the nucleus, the particle that resides are the stable particles that resides inside the nucleus are protons and neutrons. Protons and neutrons are almost of same mass, not exactly same, but for a practical purpose we can consider that the mass of proton and neutron are almost same. Neutron is slightly heavy, so if they are almost same, I can consider mass of a proton almost equal to mass of a neutron is equal to m, because each nucleon is considered of same mass. Now let us consider a nucleus ZXA. ZXA. Now, what is the total mass of the nucleons that I can measure? Total mass of the nucleons. Let that be M. Capital. I write it. Total mass of the nucleons. Can I write? It is just A into M. Total mass of the nucleons, A into M. Because A is the mass number, means number of nucleons. Each nucleus is considered as mass M. So it is A into M, total mass. Now, I want to measure density, rho. That is equal to mass by volume. We can consider mass equal to AM. Now, what about the volume of a nucleus of radius r? It is spherical. So, volume will be 4/3 pi r cube. So, put 4/3 pi r cube. But what is r? R naught a to the power 1/3. So, it will be r naught cube a. It shows that nuclear density is almost same for every element. So sodium, iron, gold, silver, copper, all nucleus are almost equally dense. There is not different density of the nucleus. Nuclear density is almost same. Because see, entire term in the density is now constant. A is cancelled. So small m, that is the mass of the nucleus, which is constant. R0 is constant. 4/3 pi is also constant. So mass of the nucleus will become, density of the nucleus will become constant. Okay. So whenever this type of question asked, so write down that all nucleus are equally dense. Density of the nucleus always same. They will not, it will not differ from element to element. Even if you can consider the gaseous element, their density of the nucleus is also same, no change. Okay. Done. So this is the nuclear portion, and one more chapter left, that is the atomic structure. So we will do atomic structure tomorrow's class. Today remaining portion we will discuss some questions and all this. Okay. Because there is still 2 more days left. So go a bit slowly. Okay. So the portions that we have already discussed in the previous visits. So let's check how many of you remember those things. See, give you certain problems, certain questions, such that first I will ask you a simple question. Write down. Statement number 1. Statement number 1. Write down. Shortest distance between two points between initial and final points. Shortest distance between initial and final points is called displacement. Okay. Number 2. Change in position vector is called displacement. Change in position vector is called displacement. Number 3. Magnitude of instantaneous velocity is called speed. Magnitude of instantaneous velocity is called speed. Option 4. Question number 4 statement. Rate of change of magnitude of position vector. Rate of change of magnitude of position vector is called speed. Okay, the question is find out the correct options. Find out the correct options. Two options are correct in this question and 2 are wrong. Which 2? 1 correct and 3 correct. Why is the second is not correct? Displacement? Displacement means itself vector. Displacement and displacement vectors are same.
So 1 and 2 are correct and 3 and 4 are wrong.
Acha. Irrespective of the surface, you have to join them by a straight line using vector subtraction. Means final position vector minus initial position vector. So that is the definition, proper definition of displacement. And second one, dr dt gives you instantaneous velocity, so its magnitude is speed. Not only the ddt of only magnitude of r vector will give you the speed. That is simply giving the rate of change of magnitude of position vector, but that is not speed. Speed means magnitude of velocity vector at any point. Okay, so that's why 1 and 3, these 2 are only correct. Okay. Next, what are the minimum number of non-parallel forces? What are the minimum number of non-parallel forces? Means parallel, anti-parallel, both not there. Forces to produce resultant force 0. To produce resultant force 0. Non-parallel means they cannot be like this, so they cannot cancel each other. So now two forces, if they are equal and opposite magnitude, they can cancel each other, but in that case they should be either parallel or along same direction, anti-parallel. But that possibility is cancelled, as it is given that non-parallel. So how many non-parallel can produce 0 force? 3. Because then these 3 forces can be represented by the sides of a triangle when all sides are taken in same order. And you know that this corresponds to another theorem in mechanics, that is called Lami's theorem, that 3 forces like this all forces F1, F2 and F3 all should be taken in same order, such that F1 plus F2 plus F3 will become 0. Because if it is given that the forces can be parallel or anti-parallel, then 2 is the minimum number, because plus F minus F, that can cancel. But since they are non-parallel, so at least 3 are required. Okay. Done? Write down another problem. A particle is thrown upward. A particle is thrown upward with velocity u. With velocity u. After time t equal to 3u square by 2g, after time t equal to 3u square by 2g, okay, what will be its distance traveled? What will be its distance traveled? Acha, just a minute, just change this one. 3/4, write down 3/4, that term 3/4 u square by g. After time 3/4 u square by g, what will be its distance travelled? See, whenever we have this type of problem, we will consider that this is the ground level from which it is particle is thrown with velocity u. So after certain time, how much it will rise. So we simply calculate it by using this equation, s equal to ut minus half gt square. Okay, so it will be u into, what is the time given? 3/4. 3/4 u square by g. Oh, it should be u by g, not u square. Dimension will not match. write it u by g, not u square. Okay, u by g, 3 by 4 u by g. Then it will be minus half gt square, that is half g into u square by g square. Sorry, this one is half g into 3 by 4 u by g, 3 by 4 u by g. So it will be 9 u square by 16 g square. Will cancel. Here it will become 3 by 4 minus 9 by 32, and u square by g can be taken common. Okay, then calculate 32, 8, 24 minus 9 into u square by 2g. So 24 minus 9 means 15. So it is coming 15 u square by 2g. Now this is the displacement. কত বললাম আমরা? 8 24 minus 9, 24 minus 9 means 15. 15 by 32. 32 এটা এইখানটা একটা কি লেখা হয়, হ্যাঁ, ইউ স্কোয়ার বাই জি, 15 ইউ স্কোয়ার বাই 32 জি. Okay, now this is the displacement, but in the question it is asked distance travelled. Here distance is the displacement, but remember, in this type of problem, in all the cases you cannot solve in this method. If it is given, in this case distance travelled and displacement will be equal, because the time that is mentioned, that is 3u by 4g. Now can we predict here that distance travelled and displacement, these two are equal? If yes, then why? Less than time of ascent, because this time after which you have to calculate the distance travelled is less than the time of ascent of the particle. Time of ascent means u by g. So it is less than that, means the particle is yet to reach the topmost position. So in that case its direction of motion is not changed. So the distance travelled and displacement will be equal. Now if the time given for this problem, if it is 3 by 2 u by g, then in this method you cannot solve the problem, because 3 by 2 u by g means 3 by 2 times of the u by g, means it is going to the top and then in the remaining time it is coming down. So the displacement will decrease, but distance travelled goes on increasing, because if it is going to the top and then falling a little bit, then displacement will decrease because the direction of motion is changed. But distance travelled being a scalar quantity, it will not change, so its value will continue to increase. So you have to calculate in different parts up to the time of ascent and then the remaining time during which it is falling. So two portion has to be calculated separately. Okay, so whenever this type of problem is given, first check the time that is that is given in the problem, after which you have to calculate the distance traveled. Whether that time is less than time of ascent or greater than time of ascent. If it is less than time of ascent, then normal displacement calculation will give you the correct answer for distance traveled also. But if it is greater than the time of ascent, means reaching to the top, particle is now going back, coming down. So the distance traveled and displacement are not equal in magnitude. So write down, if the time of ascent, if the time given in the question, if the time given in the question is less than time of ascent, if the time given in the question is less than time of ascent, okay, then distance traveled and displacement are equal, then distance traveled and displacement are equal, okay, and we can use S equal to ut minus half gt square, and we can use S equal to ut minus half gt square for calculating distance traveled, for calculating distance traveled. Okay.
So what is the value of time of ascent?
U by g. Time of ascent means where velocity is 0, final velocity is 0, initially u, so v equal to u minus gt, so 0 equal to g u minus gt, so t equal to u by g, time of ascent. Now second part, if the time given in the question, if the time given in the question is greater than time of ascent, is greater than time of ascent, then displacement can be calculated by this equation, means S equal to ut minus half gt square. Displacement can be calculated by S equal to ut minus half gt square, but distance travel cannot be calculated directly from this equation, but distance traveled cannot be calculated directly from this equation, okay. Cannot be calculated from this equation. We have to calculate the distance traveled separately for two parts. One is going up, other is partially going down. We have to calculate the distance traveled separately for the two parts and add. Okay, next. Which one is the correct statement? Why not A? Because force and normal reaction both are vector quantities. Friction force is vector, normal reaction is also a vector, so why not A?
Because friction and normal is in different direction.
Friction and normal reactions are perpendicular to each other. If you consider equation A, first option A is correct, then you have to consider that F equal to some numerical number times n, which implies that these two vectors are parallel to each other. But friction force is along the surface, oppositely directed, contact force, and normal reaction is perpendicular to the surface. So they are not related by the vector equation. Only the magnitude of friction is mu times normal reaction. So the correct relation is C only. And other things are given, cross product, dot product, those are not at all correct. So only confusion comes with option A, and that can be nullified because F and N are perpendicular to each other. If you consider any vector equal to some constant number times other vector, means those vectors are parallel to each other. Okay, since they are all, we know that they are perpendicular to each other, so there is no vector relation holds between them. Only the magnitude of friction is obeying the relation mu n. Okay, so that is the only correct option. Now next question. There are two objects, cubical object, one of mass m1, another of mass m2. They are placed over a rough surface having coefficient of friction mu. Between both the block and the surface have coefficient of friction mu between them. They are touching each other, horizontal surface. Okay. Now suddenly, by applying a constant acceleration, you pull this floor. This is placed, suppose, over some membrane, and suddenly the membrane is pulled. Okay, with a constant acceleration A in this direction. What is the reaction force acting between the surfaces of the blocks in contact? What is the reaction force acting between the surfaces of the block which are in contact with each other? Option is A, m1 plus m2 into A. Option B, M1 plus M2 into G. Option C, M1 plus M2A. Mu times M1 plus M2 into A. In the contact surface will become 0. Now how it comes? So none of this will be the correct option. So simply we will draw the free body diagram for each block. Check. This is the first block, M1. This is the second block, M2. So what are the forces? I will draw all the forces. First one is M1G. There should be from the ground there is a normal reaction N1. In the contact surface we considered that this object exerts a force on this, that is R1. This will exert the same force and both force will be same. R1, R2 will be same because they are considering the action and reaction between them. So if it exerts a force R, it will exert the force R. So that R is asked to calculate, not the N. Now here M2G, here N2, all this. Now see, due to the pseudo force, this object will experience a pseudo force M1A. This object will experience pseudo force where? M2A. Okay? M1A, M2A. Little bit. This one different, R is there and now this is filling M2A. Now see, since both the objects has a tendency to move over the carpet in the opposite direction, so there will be some friction preventing this motion. So where in which direction friction acts? On this, friction acts on this side, that is in F1. F1. On this side friction acts here F2. Okay. Now we are considering pseudo force, means which frame of reference we are considering? Non-inertial. And with respect to the non-inertial frame, this object are now at rest. So for horizontal equilibrium you can write there are two horizontal forces, MA, M1A and R plus M1A, that is equal to F1. For horizontal equilibrium from the non-inertial frame, M1A plus R, that should be equal to F1 net force. So they are balancing each other since we are measuring all the things from the non-inertial frame. Now From this you can write F1 equal to, what is F1? F1 equal to mu m1g, because for vertical equilibrium you can write N1 equal to mg. N1 equal to mg means finally we can write R minus mu m R plus m1a equal to mu m1g. Okay, R plus m1a equal to mu m1g. Now what is m1a from this? That is mu m1g minus R. Okay, R plus m1a equal to F1. So F1 can be written as mu m1g. Then we can write m1a equal to mu m1g minus R. So this is my first equation. Similarly, I will want to write the horizontal equilibrium equation for M2. See how many horizontal forces are there? 3. Among them R and F2 are directed in the same direction and M2A is in the opposite direction. So can I write M2A equal to F2 plus R? For horizontal equilibrium of mass M2, I can write that horizontal forces will balance each other. So horizontal forces, M2 is on that direction, R is along this, F2 is along this. So A should be equal to F2 plus R. Now similarly for vertical equilibrium I can again write N2 equal to M2G. So what is F2? Mu M2G. So I will substitute M2A equal to mu M2G plus R. Now divide these two equations. Equation 1 divided by equation 2. Just divide. A will cancel. Then you can find the value of R. Calculate and you will get 0. So it will be M1 by M2 equal to mu M1G minus R by mu M2G plus R. Just cross multiply now. After dividing equation 1 by equation 2, A will cancel, you will get M1 by M2 equal to mu M1G minus R by mu M2G plus R. Just cross multiply. So R will be coming 0. Okay. First term will be mu M1 M2G plus M1 R equal to mu M1 M2G minus M2 R. A. So it is coming M1 plus M2 into R, that is equal to 0, implies R equal to 0. So no reaction. So here none of this is the correct option. Because I deliberately give that none of this option, because if I write 0 then anyone will think that there is only number, so that can be the answer. So none of this Whenever there is a none of this, we have a tendency to ignore that option. Okay. Now, okay. Another question is there. Write down. Centripetal acceleration of a particle is given by k square r t square. Centripetal acceleration of a particle moving in a circle is given by this one. Okay. Calculate the instantaneous power delivered to the particle. Calculate the instantaneous power delivered to the particle, where its instantaneous velocity is v. Achha, answer will come in terms of k, r and t that is mentioned in the question. K, r and t that is mentioned in the question, answer will come in terms of this. And you can only consider that mass of the particle is m. M can be in the answer. Mass of the particle.
Instantaneous power
means at any instant. Power means force into velocity. That is instantaneous power. Actually, dot product of force and velocity. F dot v. আচ্ছা, ফার্স্ট একটা কোশ্চেন আছে। The question is, if the particle is moving in a circle, then what is the direction between its force and velocity? Force on the particle and velocity. What is the direction between force and velocity vector? Perpendicular. Then what should be instantaneous power? But you forget, this is not correct. You give me the wrong answer. If the particle, I am saying that if the particle moving in a circle, then what is the direct angle between its velocity vector and force vector? I am not saying it is moving in uniform circular motion. It may move like this, that speed will increase. It may be non-uniform circular motion. See, in the uniform circular motion, centripetal acceleration is v square by r. And see here, it is depending on time. Means the particle is not performing uniform, not moving with uniform speed. It is not an example of uniform circular motion. It is circular motion but non-uniform. So that's why in acceleration vector, centripetal acceleration is a function of time. Okay, so the speed of the particle is continuously changing. So now what happens? We can calculate that its form is v square by r, we know.
Sir, but centripetal acceleration cannot change speed. Only tangential acceleration changes speed.
আছে তো এখানে ট্যানজেনশিয়ালটা আছে। So v square by r is centripetal acceleration, so it will be k square rt square, just multiply r, so you will get v square equal to k square r square t square. So what is v? K r t. Is the velocity vector's magnitude constant? No, so speed is not constant, function of time. So variable speed, so it is non-uniform circular motion, so there must be some tangential acceleration. Because now I calculate dvdt. Dvdt will give you tangential acceleration as kr. So multiplying this one with force, you will get the tangential force. So tangential force Ft will become mkr. Because centripetal force is always perpendicular to velocity, so it cannot produce any power because it's a no work force. But now this, due to this tangential acceleration, since the magnitude of velocity is changing, there is a tangential force which is along the same direction as that of the tangential velocity. Tangential velocity is instantaneous velocity. So what is instantaneous power? P equal to this tangential force into velocity into cos, both are along the same direction. So mkr into krt, that is mk square r square t. This is the instantaneous power, mk square r square t. So first, from the centripetal acceleration we calculate the velocity, that is speed's magnitude. Then since it is non-uniform circular motion, so we differentiate dvdt. This will give us tangential acceleration's magnitude. Tangential acceleration means there should be a tangential force. So multiplying by mass we get that tangential force, and then tangential force and tangential velocity, these are along the same direction, so this can be produced power. Because centripetal and tangential velocity are perpendicular, so if there is uniform circular motion, only centripetal force is there, it cannot produce any power because it's a no work force. But tangential force means non-uniform circular motion, so it can deliver power such that the magnitude of the velocity will now change. So still it moves in a circle, but it will move at either at a faster velocity, magnitude speed, or at a slower speed. Okay. So whenever this type of question comes, don't get panicked, just try to differentiate. Centripetal acceleration v square by r, we know if it is function of time means it is non-uniform circular motion. Okay, now so remember, in case of circular motion, if it is uniform, then only centripetal acceleration is present. If it is non-uniform, centripetal is present as well as a tangential acceleration must present. Clear? This, due to that tangential acceleration, tangential force will come which can do work, and for which power delivered will not be zero, because centripetal is a no work force, but tangential force is not a no work force. So write down this point: centripetal force is a no work force, but in a non-uniform circular motion, a tangential force is present tangential force is also present, means centripetal is there, additionally there is a tangential force also, and tangential force is not a no work force, so it can deliver power. So it can deliver power. Centripetal is a no work force, but tangential force is not a no work force, so it can deliver power. Okay. Now write down two vectors are given. Vector A equal to I cap minus j cap plus k cap, and vector B equal to 2I cap minus k cap. If these two vectors represents the two sides of a triangle, diverging from same point, means they are directed like this, diverging from same point. Then find the magnitude of area of that triangle. Find the magnitude of area of that triangle. You have to calculate this one, that is half mod A cross B, that is the area of the triangle formed by these two vectors. If it is the parallelogram, then it will be simply mod A cross B. For the triangle, it will be half of mod A cross B. Okay. Okay. There is another session from 10 to, no, 9:30 to 10:40. Okay. Fine, there is no other change, but show me it in the ray diagram. We can show, in fact. See. We can consider the object here. So first light ray that we consider is passing through focus. This light ray will be parallel to the principal axis. Okay. Now consider any other light ray. But see, we know only three known paths. One is if the light ray is parallel to the principal axis, then it will be passing through focus. If the light ray passing through focus, it will be parallel to the principal axis. And if the light ray passes through center of curvature, then it will retrace its path. So the light ray passes through focus, that will be parallel to the principal axis, that I can draw. But now the other two, think, can we draw? Light ray parallel to the principal axis will be passing through focus. Light ray parallel to the principal axis will not fall on the mirror in this case. So that light ray you cannot draw. Okay, fine. Any other light ray? Better take. Light ray passes through the center of curvature. That will also not fall on the mirror. Then how to locate the image? Then how to locate that image? See, whenever we say that these three are the known path of the light, that does not mean the other path of the light are not present. Those are present. But where? Take this one. I consider any light ray, any one, any path. I consider any one point here. Suppose this point. And from C I join that line. Any arbitrary point P. Say this is pole normally considered, so this one is Q. I consider any arbitrary point. Now see, CQ can be considered as radius. CQ can be considered as radius, and radius at this point will behave like normal, because radius will be perpendicular to the tangent. So at this near the point Q we can consider just like a plane mirror, and where this radius will behave like normal. Then consider one light ray is coming from this point and falls at Q. Then this angle is angle of incidence, right? Then angle of reflection should be equal to angle of incidence. Like this. এটা আবার এদিকে চলে এলো কোথা দিয়ে? হ্যাঁ, like this. So from this, if you draw, this one will be your image, I prime. This one is the object, O prime. because this is angle I, so this angle should be I. Because don't think that only those 3 points that is mainly mentioned. One is the light ray parallel to the principal axis will pass through focus, light ray passing through focus will be parallel to principal axis, light ray passes through center of curvature will retrace its path. That does not mean only these 3 paths you can take. You can take various paths by only obeying the relationship I equal to R, because that is only the law of reflection. So considering any arbitrary point, if you draw an angle I, then following the same angle I, you can fulfill the law of reflection and draw another reflected light such that these 2 light will intersect at some point beyond C. From that, drop a perpendicular on the principal axis and you can locate the image. Okay, so even if half portion is broken, there is no problem. We can draw the full image, only the intensity of the image will be half. Done? Complete this diagram. Okay, now where are those geometric tools? It is coming or not? Reshape shunt. This one is a circle of radius r, which is made of a uniform cross-sectional wear. The two wears which are connected at the two ends of this circular loop, these are also of same material, same wear. Now this portion is infinitely long on this side and this side is attached to the circular loop. This portion is attached to the circular loop and on the other side it is again extended up to infinity. Okay. Now I current, steady current is flowing and I is coming from infinity and there I is going to infinity. Okay. The two portions of the wire, they are if these two wire portions are extended, then they will meet here at an angle 90 degree. There is no such wire like this and then here. The green portion is only the wire. Now find the magnetic field at the center of the circle. Find the magnetic field at the center of the circle for this setup. Okay. See, for the first part of the wire, this portion, there will be no contribution to the magnetic field at this point because this point lies along the length of that wire. So this portion's contribution will be 0. Now consider that after coming to this point, current is divided into two parts because they are parallel combination. I1 and suppose here is I2. Okay. Now consider here that we can consider now that I1 plus I2, that should be equal to I, because in the parallel combination if it branches according to Kirchhoff current rule, I1 plus I2 equal to I. Now if I consider this part, upper part has a resistance R1 and lower part has some resistance R2, then these are parallel combinations, so we can write I1 R1 equal to I2 R2. I1 R1 should be equal to I2 R2 because these two are branching and again joining, so they are parallel. Okay. Now from this I1, now R1 can be written as rho L by A, so it will be rho L1 by A and it will be I2 equal to rho L2 by A because area of cross section is given same, so both A are same, so rho A both will cancel from both sides. Now I1, what is L1? L1 is the length of this part, that is 3/4 of the circumference, that is 3/4 into 2 pi small r. Circumference is 2 pi r, so L1 means the length of the upper portion of the wire, this portion of the wire, so that will be 3/4 of the circumference. So I can write this is 3/4 into 2 pi r, then it is I2 equal to L2. L2 means 1/4 of the circumference, so that is 1/4 into 2 pi r. Okay, this portion L2, so that is 1/4 of the entire circumference. Now check 2 pi r, 2 pi r will cancel, 4, this 4 will cancel, so I can write 3I1 equal to I2. 3I1 equal to I2. Now you have two equations. Equation 1 and 2. Find the value of I1 and I2. Just find the value of I1 and I2. You have two equations. One is I1 plus I2 equal to I. Another is 3I1 equal to I2. Means it is coming I1 equal to what? I by 4. I1 equal to I by 4. Just substitute I2 equal to 3I1 in the first equation. So it will be 4I1 equal to I. So I1 equal to I by 4. I1 is coming I by 4. So similarly I can write I2 will be 3I by 4. I2 will be 3I by 4. Okay. Now let us consider this upper portion of the wire produces a magnetic field at the center, that is B1. Upper portion of the wire produces a magnetic field B1. So I write B1 equal to mu naught I by 4 pi r. Sorry, mu naught I1 by 4 pi r. Because in the upper portion, upper half current is I1. So it is mu naught I1 by 4 pi r into angle subtended at the center by that arc. So what is that angle? When for this arc, what is the angle? 3 pi by 2. Okay, 3 pi by 2. So now put the values. Mu naught by 4 pi r into I1. What is I1? I by, so write I by 4 into 3 pi by 2. Now we consider that lower half contributes to a field, to this field, lower half this portion arc. So let us consider its contribution is B2. Then we can calculate B2 also. Check what is B2 coming. For B2, it will be mu naught I2 by 4 pi r. What is the angle? Pi by 2. This arc subtends an angle only pi by 2. But now put the value of I2. It will be mu naught by 4 pi r into 3 pi by 2. Sorry, 3I by. Value of the current is I2, means 3I by 4 into pi by 2. Now check B1 and B2 are equal in magnitude. B1 and B2 comes equal in magnitude. Okay. Because in the larger arc, current is smaller. Because larger arc have larger length, so radius is resistance is large. Resistance large means in parallel combination small current will flow, and smaller arc is low resistance, so through that large current will flow. As a result, both will produce same magnetic field but in opposite direction. Check B1. Place your thumb along this I1 and rotate. So at the center for B1 it is going inward. Place your thumb along this current and at the center this B2 will coming out. So B1 and B2 will cancel each other. So together B1 B2 produces nothing. So what left? Only this one. This is a semicircular part, semicircular wire. One side is infinity, other side at this side. So the net field at the center will be B equal to only for the second last part, that is mu naught I by 4 pi r, and it is directed out of the board. So this is the answer. So whenever this type of situation comes, parallel combination for whatever be, immediate consider that entire loop cannot produce any field. So net contribution will be 0, first part will be 0 because it is on the line, only the last part contributes to the magnetic field. Magnetic field will be mu naught I by 4 pi r. If this situation arises for a circle, no need to calculate this part. I will show the calculation here, but in the exam if it comes, you can directly write that this larger arc and smaller arc together, since they are in parallel, they will produce no field. But remember, they should be parallel, then they will produce no field and entire circle should be completed. Another problem is there in which circle is not completed, like this, then this contribution is not 0. This should form a parallel branch. Only when it will form the parallel branch if this portion is joined, otherwise not. Then if you find this portion is joined, no need to calculate this. Directly you can write that entire contribution will be 0. Okay. Now, okay, one more question. Discuss. Suppose inside a container there is mercury. It is partially filled with mercury. Now, a solid spherical cork, spherical object is floating in the mercury in half immersed condition. A solid spherical object is floating in the mercury in half immersed condition. Okay. Now some water is poured in the beaker. Will the volume of the sphere immerse more? Sphere will immerse more in mercury or immerse less in mercury or remain same? Means the volume of the sphere that is immersed in mercury will increase, will decrease, or it will remain same. See, water is given by that amount such that this much amount water is given. That entire body is now under the liquid. Then what will happen? Immersed portion of the volume in the mercury will increase, immersed volume in the mercury will decrease, it will remain same. Weight is balanced by buoyant force given by mercury initially. So initially we can write W will be equal to BHG, because buoyant force produced by mercury will balance the weight, that's why the sphere will float. Okay. Now, if you pour certain amount of water, then I can say that it is still floating, means buoyant force of water plus buoyant force of mercury will balance the weight. Buoyant force of water plus buoyant force of mercury are acting on the sphere. Both will balance the weight of the sphere. Two liquids are now giving buoyant force, because some portion is immersed in mercury, some portion is immersed in water. So both will give the buoyant force, and buoyant force are always upward. Now from these two equations I can write that BHG prime is less than BHG. BHG prime is less than BHG, because in the second case water will produce some amount of buoyant force to such that the body can float. So only mercury alone will not apply the buoyant force. So we can consider that if both equal to W, then buoyant force of mercury will be reduced. Buoyant force of mercury will be reduced when we add water. Okay. Now, buoyant force means the portion of the volume that is immersed in mercury. Let us consider now V prime is the portion of the volume immersed in mercury. Density of mercury into G less than let us consider previously the V volume of the solid is inside the mercury into rho mercury into G. So what we will get? Immersed volume of the mercury will decrease. Immersed volume in the mercury will decrease, because now some buoyant force is provided by water, so that much amount will now not be inside the mercury. So inside the mercury the volume will be decreased. So because remaining part of the buoyant force is taken care by water. Water will provide one part of the buoyant force which will be required for the balancing W. Remaining force is provided by mercury. So that means the mercury's buoyant force will decrease, means immersed volume in the mercury should decrease. Okay. Okay, many of you are looking very tired and ready to sleep. Okay.